Hello and welcome. My name is Alberto Marquez. This presentation is about designing distribution networks and the applications to online sales. While designing networks, there are several goals to consider. The two most important are being cost-effective and providing competitive customer service. A conceptual map of the discussion includes first, the determination of the logistic factors that influence distribution network design. These are inventories, transportation, facilities, and information. Notice that these are also identified as drivers of the supply chain. While taking decisions of the network that is to be built, it's important to understand the trade-offs of the logistics factors, key performance indicators, cost, and service. Notice that to serve the same market, more than one network is possible, since they will compete with different strategies on service and cost. After understanding the trade-off, we can understand that there can be many different combinations of distribution networks. In the reading assignment discussion, 6 are presented. However, there are many different combinations and we will discuss that later in this presentation. The main agents in the network are usually manufacturers, wholesale storage centers, retailers, and customers. Each one of these can use different alternatives for connectivity of information flow, orders, product flow, delivery, and cash payments. The many different types of delivery, for instance, include direct shipping, carrier delivery, last mile delivery, and customer pickup. Similarly, there are different ways to connect with clients for orders and payments, including face-to-face interaction, phone, online, and others. Of particular interest today is the online supply chain networks, which are transforming the supply chain, breaking barriers for integration of different players in the market space, and creating new business opportunities. Several types of trade-offs are presented in the supply chain. Considering first the trade-off of number of facilities and the response time, usually the larger the number of facilities, the faster the response time, since there will be a closer facility if there are more facilities than if there are few. However, that creates an impact in the inventory. Since in many instances the demand is not known, that implies that a particular order could be placed from more than one location. If there are more facilities, we will need to have more inventory, that is, inventory in each facility, in case the order arrives in that specific facility. So the more facilities, the larger the amount of inventory that we need, because we need to duplicate the safety inventory in every instance. In general, we can avoid that if we centralize the operation to a fewer facilities, but then the customer may have to wait longer to be able to use the product. When considering the trade-off of number of facilities and transportation cost, at first, the more facilities, the smaller the cost, because the long-haul cost is absorbed in bulk with full load trucks or FTL. However, there is a sweet spot, an ideal number of facilities to reduce the transportation cost. The reason for that is that the larger the number of facilities, the more spread the transportation will be, probably splitting the cargo into less than full load trucks. This situation of less than full load truck can happen before or after the last facility to serve the customer. When comparing the number of facilities and the cost of such facilities, the larger the number of facilities, the larger the cost. This is a nonlinear function. It doesn't follow a simple straight line. This is what is known as a step function. This adds to the complexity of modeling for the optimal decision on the best option. When obtaining the total cost for the number of facilities, we see that it is not linear again, and there is an optimal minimum cost. However, the trade-off has to consider also the strategic decision of best customer service associated to the strategy of the company. Let's consider a real case scenario. A US global corporation, Fortune 100 company, has manufacturing facilities in Mexico City. They manufacture and distribute consumer products in all the country. The network includes a centralized warehouse, 5 regional distribution depots, and 1 regional cargo dispatcher. The depots are localized in the north and west of the country, where the economic development allows for wider streets, industrial deliveries, with modern warehousing facilities. The north and west part of the country have developed more industrial activities linked to the economies of the USA and Canada. The economic activity, the freeways, and the city infrastructure allow to call for full load truck, 18-wheelers, to ship to the depots or directly to large customers from the central warehouse. The delivery time is depending on the location, from next day delivery to 7 days. The customers that do not require full load truck can receive orders from the regional depots, reducing the response time by receiving orders in 13, 10, or 3.5 ton trucks. The customers on the central and south parts of the country are served directly from the central warehouse. With very few exceptions, most customers cannot receive 18-wheelers, as the traditional location of many customers are in the center of the cities, which have narrow streets with sharp corners. Many of those customers can only be reached with 13-ton or smaller trucks. For the cargo dispatcher in the Yucatan Peninsula in Merida, the cargo is shipped there in 18-wheelers and delivered within the city without a warehouse, transshipping into 3.5-ton trucks. While the operation of the depots are owned and managed by the Fortune 100 company, the cargo dispatcher serves as a contractor and has no responsibility for inventory or orders. As you can see, the network depends on many variables of the territory served. In this particular case, we can identify the size of the customer, the size of the orders, the available infrastructure, and other market conditions. For instance, the demand for 18-wheelers between Mexico City and the US border. Also included in the variables are the road condition, crossing mountains over winding and narrow roads, or freeways that allow or not all truck selection. Considering a different case, now involving another Fortune 100 company that manufactures and sells computers and other electronic equipment with manufacturing facilities in New York State and Guadalajara, Mexico. For serving the customers in Canada, they had set up a distribution center in Markham, Ontario, within the metro area of Toronto. The computers are airshipped from Guadalajara, while larger electronic equipment, about 550-pound equipment, is sent from New York State. The surprising fact is that the shipment from this distribution center has historically been serving the Caribbean because economies of scale for laptops shipped to the Caribbean helped ship the heavier equipment into the same transportation bill. Also, the reason for the cargo to be moved from Ontario instead of from Guadalajara is the availability of air shipping companies located in Ontario that facilitated a better response time than shipments directly from Guadalajara. As you can see, the supply chain allows for synergistic activity between non-competing and non-related products to take advantage of economies of scale. This is similar to the use of 18-wheelers going north of Mexico City to and from the US border. Today, these corporations use coordination between unrelated, not competing products, but compatible products of more than one firm. For instance, today the use of 4PL partners. The same truck can transport tires from one company and paper products from a different company. More on that later in the course. About online distribution, now after the pandemic and so many other events, we can see that corporations have segmented their delivery and networks both online and brick and mortar. While Walmart is going online, Amazon is starting retailing operations. There will be no differentiation of online versus brick-and-mortar companies in the future. Coordinated delivery is easier with the use of distributed information systems, artificial intelligence, data sharing, and partnering alliances. Modern strategies allow for creating of new brands, new stores, entrepreneurial activities with drop shipping and warehousing services like Amazon Fulfillment. About the future of online networks, we wonder what will happen with 3D printing, where what is delivered is not the product, but the information to print the product. What will happen with last mile delivery with the use of drones or other technologies? And what will be the preference of the customer, the fastest or the cheapest? Or maybe the customer in the future will want to wait as long as the carbon footprint is the minimum by completely integrating different deliveries from a myriad of products within blocks of our location. I hope you find this presentation useful. Please let me know what you think, and if you have any questions, we'll see you in the next one.